Uniform circular motion. Uniform circular motion is when an object moves in a circular path at a constant speed. Let's take a look at this animation to see an example. So in this animation you can see this object, it moves in a circular path and it moves with a constant speed in the circular path. Now, centripetal acceleration. That is the acceleration of an object traveling in a circle. The object travels with a constant speed as it continuously changes its direction. The acceleration points towards the center of the circular path. Now, you might be wondering, why does this object accelerate? I said that it travels with a constant speed. I underlined this right here. Now, yes, it does travel with a constant speed. However, it does not travel with a constant velocity, as its direction always changes. Remember, velocity is a vector. So because its velocity is always changing because of its direction, it is accelerating. And we say that it accelerates towards the center of the circular path. So at any point in the path of this circular object, the acceleration will always be pointing towards the center. Now, centripetal force. Centripetal force is the force that keeps an object in uniform circular motion. It always points towards the center of the circular path. So just like acceleration, at any point in the circular path, the force will be pointing towards the center of the circle. Always. So that's the centripetal force, Fc. Now, a couple of important equations. We have Fc equals mv squared over r, and AC equals v squared over r. Fc is the centripetal force, and AC is the centripetal acceleration. In addition, we have our velocity equation, which is v equals 2 pi r over t. Okay, so 2 pi r is the radius, and t is the period of the object. Okay, so no real new units here except new terms. So centripetal acceleration, that's in meters per second squared, and centripetal force, which is in newtons. But essentially, there is no new units here. The one thing I want to note, though, is Fc equals mv squared over r. I kind of want to derive this acceleration equation here. So if you remember from Newton's second law, F equals ma. Okay, so in the case of centripetal force, F equals m times v squared over r. This is how we get the centripetal acceleration. We can derive it from this equation. V squared over r is your acceleration term, which is written over here. Okay, finally, I do want to mention period. So period. Period is the amount of time it takes for an object to make one full rotation. So let's go ahead and count in this animation here. Okay, we're going to start the animation now. So we can see, well, that's one rotation, that's 2 seconds, and then another rotation. So 4 seconds, it made 2 rotations, okay, in 4 seconds. So therefore, each cycle took 2 seconds. The period is therefore 2 seconds. And the formula to calculate period is time, so the amount of time that took place, divided by the number of cycles that completed.